internally, these numbers are saved as decimals. So it doesn't matter whether you format it as decimals or not. Now, here I'm going to calculate return of portfolio or return in each of those cases. Well, the way I'm going to do it, I say total return is equal to weighted sum of the two. So all I have to do is do a cross product. So sum product of the weights, since I'm going to use exactly the same weights, I'm going to fix that. And let me do that purple, yellow. So this basically says, right now I have random. In state of very good, my portfolio is expected to return 1471. In state of good, it's expected to return 2033. In bad, 152. Negative 152. In very bad or ugly, negative 3.10. Okay? Insert a line. Going to merge and center that. Maybe make it black and white. I need to calculate, mean and stuff again, but this time for the portfolio. Some products of the probabilities, and they are going to remain fixed. Actually, it doesn't matter here. And variance is going to be some product of the probabilities with the portfolio returns twice, minus mean squared. You're probably wondering why those mean number changed. Because I have randomly selected returns. Every time the sheet is recalculated, those random numbers change. When we do specific problems, we just enter them. That's pretty much it. Now you're probably thinking, just to show you, let me calculate expected returns. For each stock or asset. Some products, sorry. And if I calculated weighted sum of those expected values, with the means of each, it's gonna give me exactly the same mean as the portfolio return. So the expected value of the portfolio return is equal to the weighted average of, or weighted sum of the individual expected return. Not a problem. Let me do the sigma as well. Let's make this black and white. Drawing a blank for the function I just used. Oh, sum product of the probabilities. And let me fix those. Return minus the mean squared. And I'm going to take the square root of everything. But if I do a sum product of the individual sigmas, or weighted sum of the individual sigmas, they happen to be the same because these are not correlated. In general, standard deviation or risk of a portfolio is not equal to the weighted portfolio weighted average of individual risks in general. That's because of correlation between those terms. Let me give you an example, and let's kind of do this with, let's do using historical data. Let's go to financeyahoo.com. Let me see. SPY is ETF for S&P 500. Let's look at the historical data. Let me see if it still gives me the data for free. Oh, I cannot download it, but I can copy paste. Let's do this. I'm gonna use this. Yeah, it gives me about a year worth of stuff. Copy. Paste. I'm gonna calculate the return here. We're gonna do it using adjusted close, because the adjusted close is returns the adjusted for dividend payments. This is for see. No, I'm gonna do it until this time. Not gonna worry about it. Before that, since this is for illustration only. Let's do another sheet. And let's do choo choo choo.